This is section 8.2 on graphs of polar equations. So we're going to start first by looking at plotting points. So a solution to a rectangular equation is a pair xy that satisfies the equation. To graph, we pick values of x and solve for y. We saw some of that perhaps in the last section. A solution to a polar equation is an ordered pair r theta. Remember those from section 8.1 that satisfies the equation. To graph, we pick values of theta and solve for r. So we're going to do that for our first example here. We're going to just make a table of pick some values of theta and find values of r. Okay, so there's the values of theta. Notice these are on the unit circle. Yeah, and then we're going to plot those and see what the graph looks like. So we start with r equals 0. And so, theta equals 0. And so to find r, it's 4 times sine of 0, which will be 4 times 0, which will be 0. For pi over 6, 4 sine of pi over 6, sine of pi over 6 is 1/2, 4 times 1/2 is 2. For pi over 4, 4 times sine of pi over 4 is 4 times root 2 over 2, which is 2 root 2. For pi over 3, 4 times the sine of pi over 3 is root 3 over 2, so that'll be 4 times root 3 over 2, that'll be 2 root 3. Alright, sine of pi over 2 is 1, 4 times 1 is 4. Sine of 2 pi over 3 is again root 3 over 2, 4 times that is 2 root 3. Sine of 3 pi over 4 is root 2 over 2, and 4 times that will be 2 root 2. Alright, notice just computation, right? Again, I'm using the equation, right? Notice I plug in the theta and just find r. Sine of 5 pi over 6 is 1/2. 4 times 1/2 is 2. And sine of pi is 0. 4 times 0 is 0. Alright, and we'll finish off the other ones. 7 pi over 6, sine is negative 1/2. 4 times that will be negative 2. Sine of 5 pi over 4 is negative root 2 over 2 times 4 will be negative 2 root 2. Sine of 4 pi over 3 is negative root 3 over 2 times 4 is negative 2 root 3. 3 pi over 2, the sine of that is negative 1 times 4 is negative 4. 5 pi over 3, the sine is negative root 3 over 2 again. 4 times is negative 2 root 3. Sine of 7 pi over 4 is negative root 2 over 2 times 4 is negative 2 root 2. Sine of 11 pi over 6 is negative 1/2 times 4 is negative 2. And then sine of 2 pi is 0 times 4 is 0. Alright, and we will plot those points. Okay, so you remember how to plot those points. So 2 pi over 6, well 0, 0 first, 0, 0, 0, 0, right? Yeah. And then 2 pi over 6, that'd be 2 pi over 6, like about right there. Alright, 2 root 2 pi over 4, 2 root 2 is about 2.8 pi over 4, so 2.8 pi over 4. Right there. What's the next one? 2 root 3. That's about 3.4 pi over 3. About right there. All right, I might miss my sum. And then pi over 2, 4, or 4 pi over 2. That'll be up here. Okay, and 2 root 3, 2 pi over 3, that's like that one, except on this side. Two root 2, 3 pi over 4. 2 root 2, 3 pi over 4. Yeah. 5 pi over 6, 2. 2 and pi 0, so pi 0. Okay, and if I go through, I start like negative 2 7 pi over 6. So if I go to negative 2 7 pi over 6, it takes me back to that point right there. I start repeating the points. 5 pi negative 2 root 2 5 pi over 4. That'll take me back over here. Okay, the next one will take me there. So I'm repeating points. If I connect these though, and we'll graph this in class, it looks like a circle is what it looks like to me. Yeah. So if I had a better measuring ruler, I'd be able to see that. It looks like a circle. Okay, let's go on to testing for symmetry. And so there's three different types of symmetries. One is with respect to the x-axis, with respect to the y-axis, and with respect to the origin. With respect to the x-axis means that if I look at the x-axis, yeah, the part of the graph above it is the same as a symmetric, right? It's a mirror image of the part of the graph below it and vice versa. Across the y-axis, same thing, except across the y-axis, right? Kind of like this one. And about the origin means that if there's a point and I rotate 180 degrees, there's a corresponding point on the other side, 180 degree. At 180 degree rotation from a given point. Okay, so like that point, 180 degree rotation would be a point over here. Yeah, or part of the graph, right? 180 degree rotation, that it would rotate over here, and so that means that if you look at a graph, that it would have the same structure here, rotated 180 degrees over here somewhere. All right, or this way, 180 degrees would be over here, right? From there, 180 degrees would be over here somewhere. All right, so how do we test? Well, so to test for symmetry around the x-axis, we replace r theta with r negative theta, and it should give us an equivalent equation. Okay, so that's what we're checking for. When we replace r theta with r negative theta, it gives us an equivalent equation. That means it's symmetric with respect to the x-axis. If we replace r theta with r pi minus theta, that's symmetric with respect to the y-axis. And if we replace r theta with negative r theta and it gives us an equivalent equation, that means there's symmetry with respect to the origin. If it does not give us an equivalent equation, that does not mean that it is not symmetric. That means that we just could not determine. We'll say it's inconclusive. Let's try a couple of these. Okay, so let's test this particular equation for symmetry. So across the x-axis first, and that's just a choice, right? So I'm going to replace r theta with r negative theta. I'll write it here. Okay, so my equation, if I replace r theta with r negative theta, would look like this. R equals 3 plus 3 sine of negative theta. Okay, if you remember that sine is an odd function, that means we can move the negative out. This would be the same as 3 minus 3 sine theta. And that's not equivalent to 3 plus 3 sine theta. So therefore, we'll say this test is inconclusive. We cannot tell if there's symmetry across the x-axis. For the y-axis, we will replace r theta with r pi minus theta. So our equation would be r equals 3 plus 3 times the sine of pi minus theta. Okay? And then I'm just going to work with pi minus theta. Remember the sine of pi minus theta. We can we have these formulas. Do you guys remember the formulas for sine pi or u plus p, I think it was called. So this will be the same as sine of pi cosine theta minus cosine pi sine theta. Yeah. Sine pi is 0. So this will be 0 times whatever's here. That'll go away. This is cosine pi is negative 1. So this is negative of negative sine theta. So this will be, this red part is just whatever we got here. So that'll be sine theta. Okay, so the equation looks the same when we plug that in, and therefore we can see there's symmetry about the y-axis. So there's symmetry across the y-axis. Symmetry across y-axis. Okay, and then finally, is it symmetric about the origin? So we replace origin. We replace r theta with negative r theta, and our equation would look like this. Negative r equals, I think I'm hiding it, negative r equals 3 plus 3 sine theta. And if we multiply by negative 1, just to solve for r, we get r equals negative 3 minus 3 sine theta. And that's not the same as 3 plus 3 sine theta. So we don't see symmetry about the origin. All right. So that means if it's symmetric about the y-axis, I can just graph from on this half, so from pi over 2 to 3 pi over 2, and then just reflect that across the y-axis. Okay, and I think I'm gonna stop here, so we know it's symmetric about the y-axis, and then pick up on the next part, on part 2 of section 8.2. Pick up there.